My name is Afolabi, and today we'll continue with our discussion on coordinate geometry. We have done previous video on coordinate geometry to introduce you to the concept of the topic. But if you have not watched it, you can go back and download and watch the video. So for today, we'll be moving on to the uses of slope. Of course, I've told you what the slope is used for and how the slope is obtained as a characteristic of the line. I told you that we could have a positive slope and we could have a negative slope. And I introduced you to the general concept of the line, and I said all lines are represented as y equal to mx plus c. This is equation of lines. Equations of lines. This is the general equation of a line. But today, we are looking at what do we really use this slope for. One of the things we use slope for is to find the angle between a line and x-axis. What is the angle between a line and the x-axis? How do we get the angle between a line and the x-axis? If you have a line, okay, and that angle, the line makes an angle of theta, the line is y equal to mx plus c, you agree with me that if this point here were to be x1, y1, and this point here was x2, y2, the angle which you have here is the same thing as the angle you have here. And the angle which you have here can be obtained as the tangent of opposites over hypotenuse. The distance we have here is y2 minus y1. The distance we have here is what? X2 minus x1. Okay? So bringing out that triangle, what we have here will be something like this: y2 minus y1, okay, x2 minus x1, and this is theta. So you agree with me from sine, cosine, and tangent that tan theta is y2 minus y1 over x2 minus x1. And this is your slope. So anytime you are looking for the angle between a line and the positive x-axis, all you need to do is to find the inverse of the slope, the angle between line and x-axis will be what? From here, the theta will be arctangent of m. Question, for example, find the angle between the line, y minus x equal to 2 and x-axis. Look at this. So we should find the angle between this line and the x-axis. All we need to do is to get the slope of the line. Remember, the angle which we are looking for, theta, is arctangent of the slope. So all I need to do is to get the slope. And from this equation, I believe we can get the slope. Look at, we have y equal to mx plus c as the general idea of every line. So can I try to write this equation as y equal to mx plus c? What we are given here is y minus x equal to 2. So moving x to the other side, I move x to the other side, y will give what? X plus 2. So if I compare with what? Y equal to mx plus c, that means my m is what? The slope, m, will give me plus 1. So if I want to calculate the angle which I'm looking for, theta, will simply be arctangent of 1. And what's the angle? 45 degrees. So anytime you want to get the angle between a line and the positive x-axis, all you need to do is to get the slope of the line. Once you get the slope of the line, the arctangent of the slope of the line represents what? The angle between the line and the x-axis. Another application of the slope, which is very, very important, is in calculating the angle between two lines. The angle between two lines. Okay, if you have two lines in your coordinate geometry system. You have a line which is y equal to m1x plus c. You have another line y equal to m2x plus c. You can be able to find this angle which is between the two lines by using the slope m1 and using the slope m2. We have two lines. This is the first line. This is line 1. Okay, and this is line 2. Now the slope of the first line and the slope of the second line can be used to determine the angle in between the two lines. I'll show you how this is being done. So the angle between the first line and the x-axis is theta 1. The angle between the second line and the x-axis is theta 2. You will all agree with me, just like the previous knowledge we have had here, there is a relationship between this angle and the slope. Yes, what's that relationship? The slope m1 is the tangent of the angle theta 1. And the slope m2 is the tangent of the angle theta 2. Then if you look at the geometry of theta 1, theta 2, and theta, you will see that theta 2 is the summation of theta and theta 1, because exterior angle is the sum of the opposite interior angle. So your theta 2 is theta plus theta 1. Exterior angle equals to sum of opposite interior angles. Okay? So that means my theta, which I'm looking for, is theta 2 minus theta 1. So what does that suggest? That simply means the tangent of theta is the same thing as the tangent of theta 2 minus theta 1. So I can apply the tangent rule here. Remember, recall that tan A minus B is what? Tan A minus tan B over 1 plus tan A tan B. So I'll apply the same thing here. I have tan theta to be equal to tan theta 2. Okay, that's tan A minus tan theta 1 divided by 1 plus tan theta 2 tan theta 1. Now, bringing back this into this expression, you can see my tan theta 1 and tan theta 2 is what I have here as m1 and m2. So that means my tan theta is what? m2 minus m1 over what? 1 plus m2 m1. So from here, I can easily find the angle between the two lines as what? The arctangent of that angle. Acute angle between two lines will be, the acute angle between the two lines will be theta equal to arctangent of the absolute value of m2 minus m1 over 1 plus m1 m2. So this is the angle between two lines. If you are told to find the acute angle between the two lines, all you need to do is to get the slope of the two lines. Remember I told you here that once you know the slope of the two lines, then you can get the acute angle between the two lines by simply using what we have on the board. That is not everything you can use slope for. We have mentioned two things you can use your slope for. You can use your slope to calculate the angle between a line and the x-axis. You can use your slope to calculate the angle between two lines. And also, you can use your slope to know the characteristics of the lines. Characteristics of the lines. The characteristics of the lines. And what is the characteristics of the line? You can use it to know if the lines are normal, that is, if they are perpendicular, or if they are orthogonal, or if they are parallel. Okay? You can use to know if they are parallel lines, which we call collinear lines. And you can use it to know perpendicular lines, which we call orthogonal lines. Okay? From the concept we have here, which we brought up from here, recall that tan theta is m2 minus m1 over 1 plus m1 m2. So this is the concept we're going to use. If they are parallel, for parallel, what does it mean? That means my theta will be 0. The angle between the two lines. Yes, if they are parallel, the angle between the two lines will be 0. So if the angle between the two lines is 0, that means the tangent will be 0. And theta will also be 0. So if I bring in 0 here, what do you have? That's 0 equal to m2 minus m1 over 1 plus m1 m2. If you cross multiply, you have m2 equal to m1. This is the condition for parallel lines. For two lines to be parallel, their gradients must be the same. Condition for parallel lines. For perpendicular lines now, this one is for parallel lines. Then for perpendicular lines, the angle between them will be 90 degrees. The angle between the two lines, here it was 0 degrees because they are parallel. Now for perpendicular lines, the angle between the two lines will be 90 degrees. And of course, tan 90 is indeterminate. So I'm going to use this in here. I'll bring it in here, 1 over 0 as m2 minus m1 over 1 plus m1 m2. If I cross multiply, I have 1 plus m1 m2 to be equal to 0. Okay, so that means m1 m2 is equal to minus 1. This is the condition for perpendicularity. Condition for perpendicularity. So for two lines to be parallel, what does it mean? That simply means their gradients must be the same for two lines to be parallel, and for them to be perpendicular, multiplication of their gradients must give you minus 1. So the application of the condition for parallelism and the condition for perpendicularity can be tested in this question here. We are given two lines. The first one is y equal to 2x plus 7. Another line is 3y equal to kx minus 1. We have to find the value of this k, which is the coefficient of x if these two lines are parallel and if they are perpendicular. Remember, if they are parallel, what happens to their slope? Their slope will be equal. If they are perpendicular, what happens to their slope? If you multiply their slope, it will give you -1. So the question is, what are the slopes of the two lines M1 and M2? So the solution, the first thing is get the slope. Get the slope. The slopes M1 and M2. And how do we get the slope? Remember I told you how to get the slope. You need to make y the subject of formula. Okay? Then you pick the coefficient of x to be your slope. So for the first line, I have y equal to 2x plus 7. For the second line, I have 3y equal to kx minus 1. So this one is already conformed to y equal to mx plus c. But this is not conformed yet. I'll make y the subject of formula here by dividing through by 3. And that means y equals to what? K over 3x minus 1 over 3. So this can be compared to y equals to mx plus c. So what will now be my slope? My slope m1 here will be 2. And my slope m2 here will be k over 3. This is the slope here, and this is the slope here. So getting the slope is the first thing. The slope of a line is always the coefficient of x by the time you make y the subject of formula. But that is not all. What will be the value of k if the two lines are parallel? For m1 and m2 to be parallel, or rather for line 1 and line 2 to be parallel, their m1 must be the same thing as m2. So I'm going to equate the two slopes. That means 2 is equal to k over 3. If I cross multiply, k equal to 6. That's the value of k when they are parallel. Now if they are perpendicular, for perpendicularity, what happens? m1, m2 must give you -1. So m1, m2 must give you -1. That means 2 times k over 3 should give you -1. And this is what? 2k over 3, or rather 2k is equal to -3, cross multiply, then k will give you -3 over 2. So if k is 6, the two lines will be parallel, and if k is -2 over 3, the two lines will be perpendicular. Remember, if there's any point in this video that you don't understand, you can always rewind it back and watch over and over again. Don't forget to drop comments. We'll see you in the next class. Thank you.